Thanks for choosing to listen to this Late Night Linux Family podcast. We're only able to do this because of the people who support us. None of our shows are paywalled, but our Patreon supporters can get most episodes early and never hear any ads. Learn more at latenightlinux.com/support or support us by telling a friend or colleague about everything we do. Hello and welcome to episode 156 of Linux Dev Time. I'm Joe.
I'm Amalith.
I'm Kevin.
And I'm Andy.
Good to talk to you all again. How deep should your understanding of a system be? Like, how deep should you go with it?
It depends on if you're in a work setting or a fun setting and what you're trying to get out of it. Right? If you're trying to learn a system, I say go as deep as you can before your eyes catch on fire or you lose interest. One of the two. But if it's for work, my answer would probably be go as deep as you need to get the task done and move off of it, sort of thing, which is sometimes a bad answer.
Sometimes I feel like I'm a perennial beginner. I'm always going just deep enough to get the task I'm doing done because I'm stressed about a deadline or whatever. So I'm talking about work mostly. And it does make me feel like there's some kind of impossible goal that I'm never reaching of actually knowing what I'm doing. The memory that comes to mind is a colleague I had where we worked somewhere with a proprietary build system. So there's this great big pile of XML files that you used to build together all your C++ into a horrific, massive blob. And the different bits of your C++ could depend on each other in different ways. And there were all these different words you could put in your XML. And I can never get motivated to learn a system like that, especially if it's proprietary. And this colleague just took the time. Like, it irritated them enough that they took the time and figured the thing out and understood how it worked. And then I just went to them with any question I had at any time and felt bad. So I wish I had the ability to go deep enough that I don't have to constantly feel like a beginner.
I think it's important to go deep on those ones that interest you, especially. And in work settings, I think it can be beneficial to go deep on ones that don't interest you, such as your colleague. I imagine there was some sort of a work incentive, right? They're the person that knows that thing the best. They get some recognition. They have some longevity. I don't know. That can actually be a detriment too, though, because I've worked with people that, and I would say I've even fallen victim to this myself, but if you feel like you have to turn over everything and see how all the bits fit together, that in a work setting is often not required and can be detrimental when you have a particular deadline or timeline. And sometimes too, like you might just say like, hey, we did the thing and it works really well. Like we understand it. You don't need to go any deeper on that thing. And if someone's like, no, I want to learn exactly how this works, can be a negative.
It can be, or it can be quite thankless and actually really valuable.
Yeah, definitely.
That reminds me of a situation I have with a colleague where I am in Andy's situation and I feel like I often only go as deep as I need to and then I get out and move on to the next thing, where he has to understand every piece. In our situation, though, I think him having to understand every piece is going to is leading to a build system where we can orchestrate and bring up test instances of every single component in our stack such that they communicate with each other with like running one command. And if he gets it to work, that's going to be absolutely amazing because I have wanted that for years and never gone deep enough to figure out how to make it happen. He is so tired of not having conveniences that he has been building his convenience.
Yeah, and I guess like I should clarify too, when I'm saying go as deep as you need to get the task done and move off, that doesn't necessarily mean do the literal minimum and move off to the next thing without understanding it. It means you need to understand the thing you're doing and probably all the parts that it touches, but you don't need to dig down into the history or all of the other advanced areas or all of the possibilities of things that could be, unless like those possibilities might be something you need coming up, in which case I would still call them either adjacent to or part of the minimum that you need to get the task done. So I think there is a distinction there between that. And I guess where I'm drawing the line is if there is not a benefit to that particular continual dive down, and the only benefit is, I would say, like self-satisfaction or just watering your curiosity, like that sort of thing, that's when I would say, at least in a work setting, you need to ask yourself if that's worth the time that you're about to spend on it. And as in there's no payback for the additional time you spend on it. Or that payback is very, very minimal, not critical sort of thing.
That makes sense.
I think that when you're doing a piece of work, especially at work, you need to be able to leave it at the end and be able to stand behind it, right? And say, I understand this sufficiently that I'm confident it does what it's supposed to do. And that's why tests are so helpful, right? Because if you write the right test, it gives you that confidence. But I do feel like during my career, I've got better at reassuring myself that the thing I'm doing works whilst not having to dig so deep into how the underlying system works. Like basically I've got good at like isolating a particular area and say writing a test around it, or just understanding that one area and saying, actually, I don't need to look further than that because I've satisfied myself that this is the specific place where this happens. And I can like literally read all of the code of this bit and say, and therefore if I add this, then this will happen. Obviously that's good for productivity, but it potentially loses a bit on me going deeper and feeling like I've got a full understanding of the larger system.
I guess the example I would use is, everybody knows I'm a Rust fanboy. I like Rust and I like digging into different and even esoteric or advanced parts of Rust. Rust then compiles down to a intermediate representation, both like Rust's intermediate representation, like I forget what it's called, like their mid-level IR, but then eventually down into LLVM IR, and then eventually down into like the assembly or opcodes. And I don't know those various intermediate representations like at all. Like I'm sure I could glance through LLVM IR and figure out what's going on, but that's not a skill set I have. Like that's an area where I've stopped going any deeper. But then interestingly, like when you get down to assembly, like that's one where I feel a little bit more comfortable than I do with one of the intermediate representations. So I would categorize that as like, I understand the part that's important to me, the syntax and the Rust source up top, as well as the thing that it turns down into, at least to some extent, the assembly at the end. But kind of all of those pieces in the middle aren't usually immediately useful to me in whatever task I'm doing. So like that would be an area that I would classify as like, I don't need to dig deeper into it unless I, happen to run into like an LLVM bug or something. But like those are areas where I think maybe I'm just curious and could want to go into those areas, but that's not immediately helpful, nor would it potentially be helpful in the general case to like my colleagues or my company or anything.
So you actually do understand the assembly then?
I would not at all classify myself as an assembly expert, but I do often find myself looking at assembly for various parts.
Right, because it's all about abstraction layers, right? Like you write it in this higher level language, and then that is kind of abstracting away what's actually happening on the CPU and the memory and everything.
Yeah, and there's also like there's various levels to this as well. Like if you asked me to go write these routines in assembly, I probably could not do it, or at least I could not do it easily. But if you asked to do certain like verifications, like what's actually happening with the optimization under the hood, that I could do pretty easily. And those parts to me, I think are important to verify because there are those levels of abstraction, but as good as compilers are, sometimes they do dumb things or sometimes they don't do things in the way that you think they're going to. So for some subsets of the program, it can be important to look at those levels. Now, this is like a very specific, like for the types of programs that I've had to write in my career. This is not a general case. And if someone were also like, hey, I write Rust, been writing Rust for 10 years and I've never looked at the assembly once before, that's perfectly fine in many, many categories.
I actually think this whole thing of like languages becoming more abstract is like an easy to believe narrative that I don't think is really true. Like one of the things that's really attractive about Rust to me is that I have a much stronger idea when I'm writing Rust code than when I'm writing Java code, for example, or Python, of what's actually happening in memory and when it's executing instructions. So in some sense, Rust is like closer to the machine, but it also provides tools that allow you to do things that feel more abstract or more powerful, but you still know much more exactly what the machine's really doing.
Yeah, you mentioned Python there. That's a perfect example of abstraction. Like what you're writing there is very abstracted away from what's actually running on the CPU, but that doesn't really matter if you want to write Python and have a certain outcome from it.
Yeah. You end up always caring more about the details, right? So now we're talking about how deep of an understanding of your language environment should you have, right? And one of the things you need to know when you're writing Python is that there's this global interpreter lock thing. So if you're running multiple threads, in many ways, they don't actually run in parallel. They all run one after the other. It's not as simple as that. And if you're writing Java, you get into like, how does the garbage collector work? And do I need to do this thing to like trick it into working the way I need it to work? You know, there's always these deep corners that you end up in, not because necessarily you're interested, but because something funny happened and you have to figure out what it was. And it's where the abstraction kind of breaks. You have to look deeper.
Yeah, and whenever that abstraction breaks, you end up having to find out what it's doing. But then in some languages, you just have no control over it directly, and you have to indirectly influence it in a way which can get really weird. And this is usually like when I would say a program is like more mature and has the either time or luxury to look at some of these things. Like this isn't usually the get the website running kind of problem. This is more like the website's been running and now we have a lot of users and we need to do some kind of optimization or something. But that's where I find like the abstraction layer, like you often do have to go a layer deeper than you would think for a particular language or whatever it may be.
I think about UFW, right? Uncomplicated firewall. I don't need to know what it's doing with NF tables or IP tables. I just need to know how to talk to UFW and have it open or close the relevant ports that I want. But I suppose the argument here is that maybe I ought to.
I don't think you ought to, but if it was your job to use UFW all day, you would come up against something it couldn't do at some point, and then you'd have to look under the covers. I think that's what I'm saying.
Yeah, exactly. And I think that's almost a perfect example of there are these abstraction layers up top where in the general case, you don't need to care. But there are cases where you may need to verify or care. And Firewall D is another one that's kind of like that, where it has a not as uncomplicated as UFW, but it is an uncomplicated syntax for most things, but then it can also have like raw rules that translate more directly into a like IP tables type rule or NF tables. And not knowing what those things are doing, what those higher level rules are doing, you may end up in a situation that has unintended consequences if you don't have tests to verify that. And that's where like Andy's thing with making sure you have the right tests to verify that the abstraction up top is in fact doing the thing that it's supposed to be doing and not leaking or allowing other stuff is a very important piece of it.
When I start thinking about leaky abstractions, I can't help thinking about the poor little high frequency traders who are writing all their code in Haskell. Because it's Haskell is like so pure and mathematical that you can like be a super smart high frequency trader and write all of your algorithms in functional code. But what you actually spend your time doing if you're doing high frequency trading with Haskell is reverse engineering how the Haskell memory model works so that you don't end up with like a million thunks all piled up on top of each other and things slowing to a crawl. So you're actually like reverse engineering the Haskell compiler in order to write Haskell code that isn't at all nice and pure and mathematical to make it run as fast as if you'd just written it in C in the first place.
The other area too that I would also look to possibly try and peer through the abstraction is if you start to reach the edges of an abstraction, as in the abstraction itself may not natively provide a way to do something, but you can maybe building blocks or Lego brick it in a way, like you can probably contort it in a way to make it do something you want. Usually that's an indicator that you should probably peer through the abstraction a little bit. So for example, like firewalls, I can't think of an exact good example of like what's an edge case that UFW doesn't quite provide, but IP tables under the hood might. But I guarantee there are probably those cases out there where it's just something a little bit outside of just, enabling or disabling a port where you want to get a little bit more fancy, but UFW doesn't provide the thing natively, so you might have to layer a few things in. In those cases, peering through the abstraction and looking down below the hood is usually a worthwhile endeavor because you can very often end up surprised. Like the people who built the abstraction may not have intended you to layer things or go and do things in such a weird and esoteric way. And you might end up with underneath, it might appear to work, but it may not actually work. Or you may end up in an area like Andy was saying, where you end up fighting the quote unquote compiler, which I don't know what that would be in the UFW case, like the UFW rule engine or something. I'm not sure.
An example of this is around SMTP and email and MM4. You can use SMTP to send emails. You can also use SMTP to send text messages using MM4, because MM4 is a protocol that facilitates multimedia messages, but it reuses the SMTP protocol with slightly different headers. Maybe they change some values. It's a little weird, but if you're using an email library, if you know that MM4 and email both rely on SMTP under the hood, you might expect an email library to allow you to send MM4 traffic, but you can't really until you go under the hood and find an SMTP library that gives you more of the components so you can make those different decisions than the opinionated higher level library.
Right, yeah. So then your depth of understanding there doesn't help you until you find the code that operates at that level of understanding.
Mm-hmm.
The more I hear about this, the more I think email is just cursed in general.
Absolutely. And so is telecom.
Don't forget text messages, they are cursed too.
Just communicating with other humans is cursed, isn't it, ultimately? But I was going to ask you about that. Is the best way to go deeper to look at the source code then and try and understand it that way?
Maybe is probably the short answer. As in, like, if we're talking about a library or something that I'm depending on, probably so, yes. If we're talking about a tool, it could also be yes. But there are other areas where it might be the whole system. So in Emily's example of like email, it might not just be looking at the source code of whatever SMTP or MM4 library or whatever I'm using. It might be like understanding the protocol as a whole or digging into how that part works. So the source might be the right thing in most cases, but in others it might be a little bit more abstract. Like we're not even talking programming at that point.
But let's just say when you find yourself without access to the source code, you're also generally a lot more lost because even if you don't often actually look at the code, that kind of project where the code is available is also the kind of project that's just more understandable in my experience anyway.
And easier to document for people who do understand the code.
Yeah.
This discussion also reminds me of a interview question that was asked of me once, and I liked it, so I've asked it in many interviews that I've given. I've probably even talked about it on the show before, but you ask a simple question such as, if I were to open up a terminal and type in ping 8.8.8.8 and hit enter, what happens? And you tell the candidate they can go like as deep as they want to go. And you will see like some candidates will start talking about how the shell interprets the text that you put in there and how the shell works, and then it calls into a binary and how the binary gets loaded into memory and all these things. Some people may talk about how the mechanical key switches and the electrical signals happen. Some people I've even heard will start talking about like the biomechanics of the human arm and how that's actuating the buttons, right? You can go in literally any direction. You can start talking about the network protocols and how ICMP works, or you can talk about the networking stack and the kernel. There's just so many directions you can go, but I like this as an interview question, especially when it's very open-ended like that. And you have to do it in a setting where the candidate feels comfortable. They know that they can give, really any answer here, but it allows you to see, one, how deep they are interested in going in a particular area. Or like, I guess sometimes you might get the answer of like, that just pings the address 8.8.8. And that's the only answer you get, right? So you might get no depth at all, in which case you might have to probe a little bit further. But it's an interesting thing to see, like, how deep does someone want to go and where are their comfort levels in a particular area that they've obviously gone very deep in before.
So through some of this conversation, I've been thinking about going deep and thinking about when I first encountered Unix or Git. I spent quite a lot of time thinking about, I could make this simpler. I could make a simpler version of this thing that gave you less additional complexity. But now I'm just so used to the way Git works, the way like find has a completely different way of providing arguments from all other commands and stuff like that, that I basically can't be bothered to do what I wanted to do at first, which was make it easier for a newcomer to this environment by making simpler tools. So is it actually unhelpful to have a deep understanding because you lose empathy for people who are trying to learn it?
Well, and also, is it a potentially dangerous thing to start looking under the hood of things? Because say you know UFW really well, and then you start looking into IP tables and F tables, suddenly you realize how much you don't know.
Mm-hmm.
And that can be dangerous, can't it? Like, it can be not necessarily dangerous, but like at least it can be discouraging.
Yeah, Git's a good example. Actually, I should say both firewalls in general and Git are probably great examples of that, where they arguably have a simple-ish upper level of usage. And yes, I would say Git has a relatively simple use case for like the base case, right? Committing and things. But then you can dive really deep into some really hairy areas that just are wild. And firewalls, I think, are exactly the same. So I guess that can be. And it's probably more of like a personality type, right? Like, are you the type of personality where you see that bottomless abyss and you either get scared and run away, or you dive into it unhealthily and like want to consume it and learn everything about it? Like, I guess it's more of an individual reaction to it.
But as for the empathy thing, I don't think that knowing loads about something necessarily means that you don't have empathy for people who don't, because you were in their position once upon a time. And again, like Kevin said, it's a personality thing, right? Like if you have a decent personality, then that comes with empathy, and you can try and explain the things that people need to know, or at least understand why they don't understand it.
For the find example, you might not have made a version with a better UX, but someone else did. FD exists. And instead of creating that, you are working on improving Element and Matrix. You're going deep in that area.
I'll tell you what is a good example for me. Crontab format. It's awful. You always have to look it up. And even when you look it up, you can't remember what it really means and whether it's a 0 for Sunday or whatever. Like, it's just a nightmare. But we don't seem to have managed to replace that with something more intuitive.
That's why like crontab.guru is always in my history, because I have to look that up all the time.
Along with chmod.calculator.
Much earlier in my career, there was this beautiful Perl library. I'm sure it still exists, but it only exists in Perl land, where you could type like English phrases for times and dates and things like that. And it just understood anything you typed. It was just amazing. Why don't we have that instead?
To me, abstractions are kind of like magic tricks. Once you see how they work, you're like, oh, okay, that's all that was, or that's how that works. And it is kind of difficult to unsee that later on when you see the abstraction. You're like, oh, well, it's technically just doing this thing under the hood. And that can be detrimental in some ways. And in other ways, it can be beneficial if you can think of either improvements or better ways to utilize that abstraction on top.
I mean, GUIs for package managers, especially the like really, really abstracted ones, maybe not quite like Synaptic, but, you know, software stores on Linux. Like, I just have no time for them now that ever since very early on, I learned that it's just a couple of commands, and that's so much easier and quicker than clicking around an interface.
I only like the GUI package managers when the system comes with multiple package managers and the GUI sort of unifies them, and I don't have to think about whether this one uses APT and this one's Flatpak and this one's Snap.
Or if it provides like something better on top. Like ideally the abstraction does something. It either simplifies something or it provides something better on top, like filtering, or exposes something more readily, or whatever it is. Like if that GUI's not doing that, it's just like being a pass through to the command underneath. And yeah, it's pretty terrible. And it's also not super helpful to me. Although, I don't know. I'm sure some people find use in them.
But that said, Gparted, I will always use. I need a GUI for that.
But just thinking of abstractions, right? One of our jobs as programmers is to create abstractions. And I think this conversation has actually helped me think about what we're doing there, right? Because I think there's two possibilities. Maybe sometimes it's both, but sometimes when you're writing an abstraction, right, you're writing a struct or whatever that abstracts some concept. Sometimes you're trying to hide the details underneath so that people don't need to understand the details. But sometimes maybe you're doing something more like what I was claiming Rust does, which is that you're structuring the way someone understands what's going on So they do understand what's going on underneath, but they're guided towards a good understanding of it and not making mistakes when they use it.
Well, on that sound point, we should probably get out of here then. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
And I've been Andy.
See you later.